Hey everybody, welcome back. This is going to be a long video. We're going to cover a lot of ground today. The main bits we're going to cover is how to get Traefik deployed. Traefik, if you're not familiar, is a web-based proxy that is built from the ground up for the containerized world. I use it for everything. I think it's amazing. I'm not going to just drop you off with, hey, let's get Traefik deployed. Let's get you started off with a good baseline of how do you set up your lab environment to even get here, get Docker installed. And I think a great place for that these days for most folks, if you don't have something at home that's suitable for your lab equipment, you can stand up a really inexpensive lab environment in AWS. We're talking less than $10 a month. And then you can reach it from anywhere, do a lot of really good experimenting right there live on the internet, which is fantastic. So today we're going to start with deploying a basic lab in AWS. We're going to use their Lightsail service to deploy a basic Debian host that we can then connect services into. Next, we're going to install Docker and Docker Compose. We're going to cover a couple housekeeping items for how to get your containers organized. Then we're going to start into Traefik. We're going to step through the configuration files, how they all relate to one another so that you understand where things go as you go off on your own. Then we'll get Traefik itself deployed, tested, demonstrate that it's running on real SSL certificates, and then we'll attach a Who Am I container to it where we can see that service running on the side and demonstrate how containers outside of Traefik auto-configure themselves. Since I can't realistically do a demonstration of every possible configuration point, let's start off with what I'm going to use for the demonstration. So again, an AWS instance in Lightsail. We're going to use AWS Route 53 as our public DNS. You'll also need to already own a domain name. You probably already have one. If you're getting this far in, you might have many of them. Pick one for your testing that you'd like to work with. Its authoritative DNS needs to be hosted in AWS Route 53. Many other providers are supported, but that's just the one that I'm going to cover here. There's too many to cover all. The next bit is the validation type for the certificate resolver that we're going to use. Traefik and Acme, which is the engine within Traefik that's being used to generate those certificates and validate. They support a lot of different validation processes. My preference is always DNS resolvers. And I'll tell you why. What the DNS resolver does, you give it permission to write a simple TXT record out. It's a random string, and then it goes out on the public internet and says, hey, can I see that this record is in place and that this string is attached? From there, it'll say that's fine, and we'll go ahead and issue it. Why is this more helpful than like HTTP or HTTPS validation? You can use this same strategy whether the server you're issuing against is actually live on the internet, which in our case it is. You could use other types, or if it's in your home lab and you want real SSL certs, not self-signed ones, that are issued out there, but that server is not live on the internet. DNS validation will still let you get that certificate even if it's not directly accessible on the internet. It's only in your private network. So you can use this method really anywhere. It's always my preference. We'll use that to get our certificate and attach it to Traefik so that we can start hanging web services off the side of it. All right, get a cup of coffee. Let's get started. So as we're getting started like all the way from the beginning, I think this is a great place for you to learn some of these areas. Hey, if you already know your way around AWS, cool, go ahead and move on, not a big deal. But for those of you that are new to AWS as a whole, this will help get you into a spot where you've got a nice test machine. It's great to have these resources in the cloud that are very inexpensive. Go find the Lightsail service within AWS. For this, we're going to go ahead and create an instance, and you're going to choose Linux, and we're going to go operating system only. I recommend sticking with Debian 12. This is the same platform you would have used if you had deployed Home Assistant supervised on your single board computer. So we're kind of sticking in that same realm there. So we'll select Debian 12 and then our sizing. So you can see we've got various sizes from $5 a month all the way up to many hundreds of dollars per month. You also get the first 90 days free on these first 3 smaller instance sizes. So this is a great way to kind of kick the tires as you're learning AWS, learning Docker, and in our particular case here, learning how to deploy Traefik. My suggestion when you're starting out here, go ahead and go for at least this $7 per month one, 1 gig of memory and 2 CPUs. So when you're dealing with containers, typically you're going to run out of memory first. Full well acknowledging for anybody here that's an AWS expert, these are burstable instances. So you're running against your burst credit threshold as well. This is not just a free-form CPU. You can go ahead and give that instance a name, hit create instance, and it'll take you back to the main screen here. If you've got other things running, you'll see them there. And it'll take a little time to go from the pending state into running. And once it's in that running state, Now we can actually remote into the machine. So quickest way to get started, it has this little kind of web shell edition here, separate window here, and just take you straight into the shell of that running instance. First thing we want to do is make sure our apt repos are up to date. Sudo apt update, and then let's get Docker installed. We'll run sudo apt install docker space docker dash compose. So that's both the Docker installation and Docker compose, two separate binaries. As always, don't scramble to try to catch these commands in real time. Link below in the description to all of these commands listed on the website. Great, got Docker loaded up. Something I also like to do is go ahead and add your local account to the Docker group so that you don't have to run all of your Docker commands prefixed with sudo all the time. So that command is sudo usermod -a capital G, the name of the group, which is Docker, and then the name of the user. And if you're using a default Lightsail instance, that's just admin. Great, so we've added that user in. You also need to log out and back in. We can exit, we can reconnect into our console, and we can run docker info. Perfect. So this will give us all of our running information about the installed Docker, which we did not prefix with sudo, which means it's working as intended. And then install htop. And with that installed, hey, look, we've got a fully running OS in the cloud, $7 a month. Awesome. Okay. Now there's more to do here as far as providing connectivity into it from the internet, because it's AWS, right? It's not sitting on your desk. It's not sitting in your closet here. You have to make sure that you plumb those through. So we'll go back to our main screen, get into the details of that, and we'll see we have our public and private IP information. Awesome. If you navigate to the networking tab, this is where we'll need to make some adjustments so that you can reach this from your home. Scroll down to the IPv4 firewall section. And in here, you're going to see by default, it's going to have SSH and just HTTP port 80. You also notice in the restricted to column, which is a super important bit here, SSH is restricted only to within Lightsail. So this is how earlier we were able to get in through that web-based SSH console. You need to keep that in play for that. If you wanted to access this from your home, plumb in just your public IP address so you don't leave this wide open to the internet. In contrast, we see port 80 is open to the internet, any IP4 address. We're going to add some additional rules in here as we move forward. Okay, so we're in a great spot here just to standing up a really quick instance. We'll load up Docker and then we'll load up Traefik. So we're covering a lot of ground here, so get yourself some coffee. Let's get this going. Next, let's go ahead and go back into those network settings. Click Add Rule. HTTPS, perfect. So now we have 22, which is just allowed here within the console, not open to the public internet. And then we do have port 80 and port 443 exposed to the public internet. Okay, before we go any further, because this is a lab environment, let's make sure we go ahead and lock down those to just your public IP address. So, you know, when we stand up Traefik, it's not going to have any authentication layers in front of it. So let's make sure that this is only accessible from your home. The first thing you'll need to do is collect your public IP address. If you already know where to find that, go ahead and grab it. If you're not super sure about that, a tool I like to use is called canhasIP. Link down in the description there to that correct spelling, and I'll throw it up here on the screen too. Start with SSH. Check this box that says restrict to IP addresses and plumb in your public IP address, okay? And then you'll hit save. Go ahead and do the same thing for HTTP and HTTPS. So at the end of it, you will not have this section where it says any IP4 address. It'll be scoped down to your public IP address. You don't want to unwittingly just have this out on the public internet without authentication in front of it, which will be important as we step into installing Traefik, which will consume all of that incoming request. You can go ahead and just turn off IP6 networking on the instance. You're not going to use it. Okay, now we're actually ready to start deploying some containers. So first, some like organization and housekeeping items. This is my personal preference. You can adjust this to your own needs and desires, but I like to put all of my compose files in a subdirectory right in my user profile. So I'm going to do make dir compose-files, and then within there, all of my actual container folders underneath that. We're going to run two separate compose files and container stacks. First one is Traefik. The other one we're going to run adjacent to this, to sort of for our testing and proofing out of the things, is we're going to use what's called a whoami container. So we'll have directories for Traefik and for whoami. Whoami is a nice container that I like to use. It gives you a lot of information as you're troubleshooting things like headers. When you're working with a proxy, it'll give you all that information right in the browser. It also gives you some validation that your proxy is working as expected. Super helpful container. Recommend you fire that up as just part of your base stack. I use it all the time. But for today, we're here for Traefik primarily. So let's start with that. We'll get into the Traefik directory, fill out a few different files here, and I want to step through each of those so you understand the layout, the architecture, what the files' relationship to each other are, and why it's going to make your life easier later on to go this way. The other thing I'm going to do at this stage is I'm going to get out of this browser-based SSH session, mainly because copying and pasting doesn't keep all the formatting and it kind of drives me crazy. So I'm going to go ahead and connect in from my home network through a regular SSH client. A couple hints you're going to need here, and I'm going to leave you to figure this piece out on your own because I think this is a great learning exercise. If you're going to go this route too and connect in from your home back up to AWS, you're going to need to modify that port 22 SSH rule in your Lightsail instance to allow traffic from your home IP address. Don't leave it open to the public internet. It's not a good idea. Tons of bots out there are just going to hammer it and try to get into it. Second, you're going to need your SSH key that you used when you generated your Lightsail instance. There'll be a default key for your account. That's kind of how Lightsail tends to work. You're going to need that to authenticate in. So see if you can figure that out. It's not too complicated. If you run into problems, hit me up in the comments below. And I can always do a separate 30-second video on just that if that's helpful. So just let me know down in the comments if you'd like to see that. So I'll see you over there on the other side. I'm gonna move on to my local client. Here we go. That's so much better. It's just so much better. We're in our Traefik folder. There we go. Nothing there. Perfect. Now we're gonna create those files and step through them. Make sure you understand what they are. First, just like any container, let's start out with our docker-compose.yaml file. Let's go ahead and step this file. This will largely work for you out of the box with a couple little adjustments. Obviously, you're not going to use my domain name. That's not going to work so well for you, but most of this is going to work out pretty well. This is also using Traefik version 3. Let's just step our file here. There's a few important bits I want to cover off. Top part here, networks. That network name is just proxy, okay? Now you'll see later we're going to reference it with Traefik_proxy, and I'll explain why that is and why that's actually the same network. Volumes, we just have a simple volume to store our certificates that are generated by Let's Encrypt. And in the services, we have our normal configuration bits, the image, the container name, restart policy, and then the open ports. You'll see we have port 80 and port 443 open and passing straight into this container. Now we open those up on our Lightsail instance to the internet. So that means that this container is going to take all of the traffic coming into this instance from the public internet or anywhere you expose it from. Again, within here, we're referencing that proxy network. And then we have a few volume mounts here to talk about. So the first one there is access to the docker.sock, which is the socket file where this container can actually watch what Docker underneath itself is doing. This is how it's going to be able to retrieve the labels in order to self-configure containers that live outside of this particular configuration. Next one there is just that Let's Encrypt volume for the SSL certs that are generated. And then we have two configuration files we're mapping in. The first one there is our Traefik.yaml. We'll step through that one next. And then same thing with this file provider YAML file. And then we have our labels section. So this is where there's some familiarity with other containers besides Traefik that are going to do their configuration into Traefik. The important difference here is within our Traefik container, towards the bottom there, you'll see I have a cert indicated here, and it's a wildcard cert. So we have a SAN name for that. So that'll generate that certificate through our certificate provider, Let's Encrypt. And then just below that, we have a few environment variables. These are how I'm passing in the secret and the key for the AWS IAM role that has permission to create a TXT file to validate the domain so that we'll issue that certificate. That's how that DNS validation works that we talked about earlier. Next up is our Traefik.yaml file. Let's go ahead and pop into there. This is the main configuration file for Traefik that we pass through from our Docker Compose file. So we're mounting this inside the Traefik container. The reason I prefer this method rather than cramming it all into the Docker Compose file is that this is a far more readable format, and you can see very clearly what's happening in here. So let's step this real generally just to make sure we see what we're doing, what we're passing into our Traefik install. First, we're defining a few things about the API. Another important bit we're defining here is our providers. Primary use here is for Docker as the provider. So we have that enabled, and it's using the proxy network. That's a very important thing. Make sure you make note of that. Next provider is our file provider. So this is another important one too. We're going to step through the file provider file. configuration next. We're just defining what that file provider is, and we're telling it to watch equals true. So that means any changes you make to that are going to automatically get asserted into Traefik without you having to restart the service. And then we have our 2 entry points. So web, just general web traffic, that's our port 80. And we're basically taking that and upgrading everything to HTTPS, or web secured as we're calling that entry point. The previous 2 other configurations are just for web traffic, which is primarily what you're going to be using, but you can also do TCP and UDP traffic right through here as well. So here I have one for a Nextcloud install where I needed to pass UDP traffic specifically for some of its functionality. So I have an entry point for that specifically. And then our next section down below is actually where our certificates come from. So our certificate resolvers, LE for Let's Encrypt, and ACME is the mechanism that renews and issues those certificates, and the type of challenge or validation that it does. So, we talked about before, you can do HTTP and you can do these other ones. I always prefer DNS challenge myself. So we're going to stick with that. For this example, we're using Route 53 as our DNS resolver in order to validate and retrieve our certificates. This will get you a good starting point, and now you know very descriptively and prescriptively where things are stored. And the last configuration file is going to be our file provider YAML. So that's file-provider YAML. Let's pop into there. So what are file providers? We've talked a lot about using labels within containers to auto-configure traffic to route your web services through. File provider is where you can actually define your own things that maybe they're not containers, or maybe they live in containers that are outside of this system or server where traffic wouldn't be able to read its labels in order to configure itself. So you can get around that by using file provider. You can define exactly where you want to send that traffic to. So if you have other like web interfaces that are on your network, you'd love to just wrap all around this, and they'll still use that same mechanism of your SSL certificates and that namespace. And just as we touched on in the other config file, there's HTTP style ones, there's TCP and UDP. So I have examples of all of those here. Let's take a quick look at a couple of those, and also a middlewares example, which is kind of a teaser for something we'll get down to a little bit later, which is a free single sign-on platform called Authentic, with a K at the end instead of a C. Authentic. Recommend you look that up. It's pretty cool. So this is kind of akin and adjacent to services like Okta or Duo or Microsoft Entra, any of these like really large, heavy-hitting identity and access management with full single sign-on and MFA, but totally free and self-hosted. We'll definitely be setting that up. This is like a little hint of what that might look like and how you can bolt that into Traefik. So we're going to skip over that middleware section a little bit because we're not really ready to talk about that quite yet. The first one here, routers. So this is where most of the things are that you're going to have are going to exist. So just like in classic Traefik form, you have routers and services. So we need to tell it, hey, first of all, when an incoming request comes in with this namespace, I'm going to send this on to somewhere. I'm going to route this to a service. So that's the router. And then the next bit here is the services. So just this example here, it's going to take this rule namespace and it's going to send that. As we look in the services, we step that configuration, we see it's going to send it on to this URL with a specified port number. I have it commented out, but this is also if you were using middlewares, Authentic, as we were talking about earlier, this is where you'd insert that, and it would tell it during that routing process, hey, I've got this request, I'm going to route it, but before I route it, I'm going to send you off to this middleware. Once you complete your tasks over there, bring you back here and send you down to that target. So routers and services are how all of your manually configured web-based systems are going to plumb into this file provider. And additionally, you can do TCP and UDP services as well, and they follow the same pattern with routers and services. We got one more file to take a look at. It's not strictly a configuration file, but it is something you're going to use a lot in Docker, or I very much encourage you to use when you see variable references, as we had seen before. And if you want an example of those variables, let's go back to our Docker Compose real quick. The very bottom here, you see in the environment section. So that is actually a variable that we're referencing in that .env file. So let's get into that .env file here. Now, of course, I do have my actual secrets and keys and things blanked out here. So yeah, not going to hand those out in a YouTube video. That wouldn't be great, would it? But you can see that this follows that pattern. So we have this AWS _key equals, and then you would have the string that represents that. So you can store that safely in here to keep that out of your main configuration file. These are free form. Anything you put into here, you can reference over in your Docker Compose file as well. Okay, with that, we're ready to actually deploy Traefik. Yay, finally. So that'll bring us back to our standard docker-compose up-d. So first thing this will do is create our Traefik_proxy network, our volumes. It's going to pull those image layers for the Traefik container. You'll see those all pull down. I want to make special note of that network name. We don't want to glance over that because that's important as we're tying other containers together into Traefik. This is an important understanding of how Docker Compose, the resources associated with that deployment, are going to be prefixed with the name of the folder that the Docker Compose file lives in. If you go back to our Docker Compose file, you'll see the network is very clearly defined as just proxy. However, we're running this from a folder called Traefik. So that means the actual name of the project from a Docker Compose perspective is folder name, Traefik _, and then the name of the actual resource. So within that Docker Compose, the network name proxy becomes Traefik_proxy. And we see that here. Traefik_proxy is the name of the network that was created. We do Docker network ls, take a look at the networks that are present on the system, clearly see Traefik_proxy is the name of that. So keep that closely in mind as we go into our other deployments, because they're going to need to reference not the network name proxy, they're going to have to call it Traefik_proxy. Okay. A lot about that, but it's really important and it'll save you a lot of frustration if you can't figure out why you can't attach to that network. That's why. Okay, so the container is going to come up. It's going to reach out to your DNS provider and it's going to create a DNS record to do validation. So the way that works, just real generally, what happens is you can't just issue a certificate for any domain out there that you don't own. That would not be good, right? The internet would be a mess. So the way DNS validation works, the Acme service within the Traefik container is going to reach into your DNS provider, which in our case is AWS Route 53. It has permissions to create DNS records. So it's going to create a TXT record with a random string in it. And then it's going to check through the public internet to make sure it sees that DNS record with that randomized string attached to it. If it's able to see that, it means that you must have control of that domain and ownership of that domain. So it's going to go ahead and say, yep, that's fine. And I'm going to issue this certificate that you've requested. Okay, so once that cert is issued, and I recommend you just kind of let your Traefik container just kind of bake for about 5 minutes because it takes a variable amount of time for that process to complete. Next, you're going to need a DNS record pointing at that fully qualified name that you gave your instance back in our config file where we defined in the labels the name of our Traefik web interface. This is going to be an A record pointing at the IP address of our Lightsail instance where Traefik is running. So that will give us a resolvable from the internet traefik.domainname.com. And if we did everything correctly, if we navigate to that fully qualified name, you'll be presented with the Traefik dashboard. This is live on the internet, running off your AWS Lightsail instance, and it has a real SSL certificate attached to it. This is not a self-signed cert. Now, if you do get a pop-up here, when you go to access this saying something about a SSL warning and you inspect that certificate and it says something about default Traefik cert, then that means if something didn't go right in your DNS validation. Check real carefully for any typos. Make sure that your AWS IAM role that you gave your key and your secret to that has all the correct permissions. Take a look down the link below. I've got links to all of the requirements for this, but just make sure that everything's in place so that it's allowed to create those validation records. If you landed here successfully with no SSL warning errors, and if you inspect that cert, you should see that it's a real issued certificate. And if we click on the HTTP tab in Traefik, this is where we'll see most of the kind of valid information that we're looking for based on our configuration. Also a good spot to point out the differences between the different providers that we used. So if we take a look at this provider column here, you'll see the Docker icon there, the little blue guy there. So this is the one that was configured purely by labels from within the container. We didn't do anything in the file provider. It configured itself based on those labels. Perfect, that's what we wanted to see. And then just the same right above that, we see this one that is coming in from the file provider. And you can see it's that @ file for the name in the purple column there. And it has that little file icon there. And also that very bottom record there, that host with the reg expression there, that is our HTTP to HTTPS upgrade. So anytime you hit one of these paths and you don't type HTTPS explicitly, it's going to automatically grab that, upgrade it to HTTPS, and move it along. Okay, let's move on to the TCP and UDP tabs. Just wanted you to see what actually is the output of those file provider entries we did previously. This is pure TCP traffic, and we can see that that configured itself within Traefik, and it's passing its way through to its destination where we intended. We can click into one of these, you'll see the router, and you'll see the service that is backing that, and that URL matches what is in the file provider. Same over in the UDP section. Sending UDP traffic in, the concepts there are still the same. You've got the router, and then you have the service that backs that and the destination that it's going to. Okay, awesome. So Traefik itself is healthy. This is the front end, the proxy of everything that's going to sit behind it. Now, let's put something other than Traefik's management UI up in front of it. So let's get into our whoami directory. So come one level down out of the Traefik folder, and then let's get into the whoami folder. We'll create our Docker compose file, nano docker-compose YAML, and we'll go ahead and populate that with our config. Now this should be fairly static for you. You'll just need to edit the fully qualified name there for the URL for the redirect rule. But other than that, this should just work out of the box for you. But let's step through this just so we understand what it's doing and why this is useful. This is our first example here of using the Traefik_proxy network. So as we talked about before, because of the folder name, the actual name of the network is Traefik_, not just proxy. So we see an example of that here. And then we also have the external true statement below that. That's telling the compose file that when you go to create this, hey, this is already the existing network, we're just going to attach to it. We're not going to try to create it. If you didn't have that line, you'd get an error when you try to deploy this container saying there's already a network out there with that name. An important note too is anything that plumbs into your traffic for your web proxy, it has to use that same network. So let's deploy this. It's pretty quick. It's a tiny little container. And don't forget to make a DNS entry that's going to match that fully qualified name for whoami. Otherwise it doesn't know how to get to it. As a good indicator that things are going well, at the very bottom now we have a new entry. That tells us it was able to plumb that together. And if we open a new browser tab and bring up that whoami.domain.com, you're just going to get a very simple output here. Now this is super helpful information for troubleshooting issues with web applications. So this tells you exactly what host headers were coming through, areas that are really hard to troubleshoot if you can't tell what is actually being passed through it. So I like to just keep this container running in my home network itself for when I'm troubleshooting different things. And then for our example here with Traefik, this shows us, hey, it's working. We're passing web services through it successfully. Traefik is a super flexible and super powerful web proxy. It's really designed from the ground up to work in a containerized world, as we can see. And I hope these examples are really helpful for you. Now that we've kind of laid the groundwork for a good Home Assistant deployment, if you followed my previous series, you can understand how to throw a web proxy in front of that, a few configuration tunings to get that to work. This is how you can also hook in all your other containers to a nice tidy web proxy with real SSL certificates. And it can be anything from actual adjacent containers within your containerized environment or things that are completely off on the side that you can issue in through that file provider. This is a tool I use every day. It's a critical piece of my infrastructure. It's a critical part of containerization. And I think setting this base foundation is going to really help you in your journey in learning containers and how to manage these workloads. If you found this helpful, please do subscribe, give me a thumbs up, and hit that notification bell so you see the next video coming in. We're going to go through a bunch more containerized things. They're going to start to hook right back into Home Assistant. These are all going to tie into that. Now that we've got a good baseline set, we can continue on and keep building. Thanks for joining me. I'll see you real soon.